to say thank you very much, everybody, for attending our webcast, where we're going to talk about bizarre, strange oddities in networks and newish style attacks. This particular technique was kind of worked through by Archangel or Justin. Justin, can you please say hi?
Hi.
There you go. He just joined the Black Hills Information Security team a little while ago, and this is his first webcast. Before we get started, I want to say this is brought to you by AI Hunter. If you're interested in finding like really advanced backdoors and beacons leaving your network, type in demo. We also have a free tool called Rita. We're happy to talk about that as well. And if you look at the MITRE attack technique matrix, go to the far right, one in, there's actually 2 columns there for command and control and data exfiltration. That area is predominantly ignored. AI Hunter and Rita is what we've created to address those far right-hand columns. So type in demo at any time, and we will set up a demo with yours truly, Chris Brenton and Bill Stearns, and we'll get you guys set up. Is brought to you by Black Hat's A Guide to Active Defense, Cyber Deception, and Hacking Back. We're currently at 71% capacity. So get in quick. It's going to be a fun class all about cyber deception and active defense. So get in on that. Also brought to you by Black Hills Information Security. The stuff that we talk about in this webcast is what we do. We break into things and we help you secure your things. And of course, Jason's been adding in a lot that Black Hills Information Security is far more than just penetration testing. Penetration testing is merely an excuse for us to develop more cool tools, do blogs, and lots of awesome webcasts, which you're now on. So Wild West Hacking Fest is coming up the 23rd through the 25th of October, with the training right before that in Deadwood, South Dakota. And I'm not overstating it whenever I say it's the greatest hacking conference in the world. It's the only hacking conference I know that everyone gets a steak dinner. We have more hands-on than you will ever be able to complete, ever. So please show up. And somebody said, how do I get the most out of Wild West Hacking Fest? Come multiple years. That's the way to do it. So let's dive in. So before we get started on this particular webcast and we start talking about the tool, we have to establish a little bit of background. Because when Justin was talking about this tool with the rest of the testers, and I was kind of talking with him about it, the technique that he used and kind of set up his tool on really has its genesis all the way back in a tool called LaBrea Tar Pit by Tom Liston. Now, this tool came out way back in the early 2000s, and the reason why Tom created this tool is we had a lot of malware. Like we had Blaster, Nachia, Welchia, all kinds of different malware that's spreading through networks very quickly. And a lot of the malware would start scanning all the IP addresses around it to find additional hosts to attack. Now, if you're trying to attack an IP address, one of the first things that you're going to do is you're going to send out an address resolution protocol request. You're going to send out an ARP, and you're going to say, who has this particular IP address, please tell. And if the system is alive, it'll respond back with its MAC address, and it'll say, I'm over here at this particular MAC address, and then they can communicate. This is a layer 2 communication on Stevens model, and it allows the systems to talk to each other on a switch. Now, the idea of LaBrea was if a system is not alive, there'll be one ARP request, and then there'll be a follow-up ARP request if there's no response to that first one. So what LaBrea does is it looks for any system that's trying to find an IP address that is non-existent, and it sees the second ARP request, and it responds back to that ARP request, and it reroutes that traffic to LaBrea Tar Pit. So that means for every single network segment, like a /24, there's going to be 256 live IP addresses on that network as far as the scanning system is concerned. Now, the vast majority of those systems are not responding, or they're slow to respond because it's all in the tar pit, but it's using up all that IP address space to slow down the ability for that system to find it. So that gives us the ability as defenders to basically trap and slow down malware that's ripping through the network. So we're setting this up as background. That's not exactly what we're talking about today, but it is some background that I think needs to be discussed. Also, let's talk a little bit about ARP cache poisoning. This is directly from SANS 504, a little bit of shout out to SANS 504, a class that Josh Wright is taking over. So with ARP cache poisoning, the way it works is the first thing you do is establish a system that configures IP forwarding. And that's because you're going to pretend to be the router. You're going to pretend to be the gateway. And we want the traffic to flow through our systems. As I say all the time, the spice must flow. So we need to make sure that traffic can flow through our computer system. Then we send a whole bunch of gratuitous ARP responses to all of the systems on that network. Now, most systems will have an ARP cache. it'll time out after 10 minutes or so. So you're constantly going to be sending these gratuitous ARPs saying, I am now the router, I am now the gateway, I am now the router, I am now the gateway. You send that about once per second to either a specific system or a bunch of systems on the network. And then once their ARP cache times out, you immediately send that gratuitous ARP response to the target computer systems. And then they will then start sending all of their traffic to you, thinking that you are the gateway. So you're pretending to be the IP address and you're overwriting the MAC address for the victim's computer systems to get to the internet. At this point, the attacker would then forward the traffic out of the network down to the default gateway and out to the outside world. So this is the beginning of a monkey in the middle or a man in the middle or a person in the middle attack so that you can see all this traffic going through your computer system. So that's setting up ARP cache poisoning. So it's important to understand LaBrea tar pits. It's important to understand ARP cache poisoning. And it's also important to understand other protocols like link local multicast name resolution, NetBIOS name services, mDNS. I would also throw WPAD into this as well. Now, the reason why these are important is what Justin's going to discuss is really similar. So if we're looking at link local multicast name resolution, somebody had asked earlier, how did this happen? And the only thing that I can adequately come up with is lots of cocaine in the Microsoft offices in Redmond back in the day. So if a Windows system cannot properly resolve the DNS entry for a computer system. If they say, well, I'm trying to connect to file server 26 and file server 26 does not exist, it doesn't have a DNS entry, then that system will broadcast out an LLMNR request and then possibly a NetBIOS name service request. It'll basically shout out to every system to a broadcast address. Who has this particular IP address? And for years, systems would scream out NetBIOS name service and they would scream out link local multicast name resolution. And then we started seeing tools like Responder start to take advantage of this. Basically, because it's a completely unverified broadcasted request for an IP address, tools like Responder can then respond and say, yes, the IP address that you're looking for is at my evil IP address. And then it can stand up a whole bunch of different services. And then when those services fire, you can actually capture credentials, whether it's over SMB. Somebody asked, does this work for NetNTLM v2? Absolutely. You can capture and crack those password hashes. And it is every bit as bad as it sounds. Taking unsolicited, unverified advice from every system on the network is just really a bad security idea. Now, here's the kick in the teeth. Whenever we're dealing with link local multicast name resolution, we still see it quite often in a number of our penetration tests. It is a very, very quick, easy way to grab password hashes, crack those password hashes, or it's also possible to redirect a system using NTLM Relay X to gain access to other computer systems and further your access on the network. So it's very, very dangerous anytime we actually see that. Once again, this slide is also from SANS 504. So a couple of notes. Admins. So why does link local multicast name resolution still persist to this day? Well, there's a lot to this story, all right? Most organizations that we're encountering, whenever we successfully attack a system with link local multicast name resolution, it's a lot of times it's an admin level system. Could be a security administrator, could be a network administrator, a Windows domain administrator. So we have a very high percentage of the systems that we attack successfully are actually admins. And the reason why is many admins don't like the default image that is put down by desktop support for their system. They want to build their system from scratch. So they basically take an ISO and they build their Windows system, Windows Professional system from scratch with just the components that they want without all the rest of the corporate fluff that is loaded on standard workstation builds. In doing that, that means that the likelihood of their system being misconfigured and having LLMNR NetBIOS name services enabled goes up quite a bit. So that's a really important thing. But we're seeing less and less LLMNR on the networks that we're testing. We still see it about once every 2 to 3 weeks, but it's less now than it was a year ago, right? The other thing is if I go back to ARP cache poisoning right here, indiscriminate ARP cache poisoning is really, really bad. It's an attack tactic for sure, but a lot of penetration testers kind of forgo and stay away from ARP cache poisoning. And the reason why is more practical than it is anything else. If you ARP cache poison an entire network segment, and let's say that your system right here, this attacker system, let's say that you're on a 1 gig network connection, right? And all of a sudden you have this system is on a 1 gig network connection. And let's say that there's like 5 other computer systems that are also on 1 gig network connections. Then all of that traffic is then going to be routed through your computer system as though you are in fact the default gateway. This can create tremendous instabilities on the network itself. So generally, as a rule, for most penetration tests, we don't actually do ARP cache poisoning as much as we used to. I remember years ago, about 10, 12 years ago, I was doing a lot of ARP cache poisoning. But sometimes if you're ARP cache poisoning just one server on the network, it will degrade performance and it'll create an impact on that network. So now let's try to tie some of this together. So Jamie has a tool called NetDiscover. And NetDiscover was designed to just find systems based on ARP requests. It'll say, here's an ARP request for this particular computer system. Here's an ARP request for this system. And it'll inventory the systems that are identified by those ARP requests. And we actually see a lot of other tools. Network Miner does something very, very, very similar as well. It'll basically identify systems on the network by their ARP requests as well. But this brings us to the attack technique that Justin is going to talk about here. He developed something, and I like the name, he called it Stale Network Address Configuration, or SNAC. And yes, this is called a SNAC attack. Once again, the main goal for all of this is rerouting. We want to reroute people that are doing LLMNR or NetBIOS name service, address resolution protocol. But with the SNAC attack, what he discovered in a couple of the pen tests, and actually I think we've had a couple of other testers find the same thing, we're finding situations where you have stale network addresses that are showing up. So we have a screenshot here to kind of set it up, and then we're going to hand it over to Justin for screen share. Hey, Justin, can you tell us a little bit about this screenshot that I have here? Like the top address request is actually the stale network address request. Can you talk a little bit about that and why that's important?
Sure, absolutely. So the key indicator here that we can see is the count of ARP requests. We see that it's measurably higher than any other count of ARP requests within this particular image. And in this case, .7 is a stale IP address that exists within the network. Maybe it was a server at some point in time. .3 is actually afflicted by the SNAC itself. So there is some sort of a client on that host that has a hard-coded IP address that points to .7. And periodically, it is going to try to access .7. And every time it does, since that IP address is not in use, it's going to generate an ARP request. So that's the key indicator of a SNAC.
And the other thing that's really important to understand from this is this takes care of, this gives you a target for ARP cache poisoning or setting up rerouting or a LaBrea style attack to reroute that traffic. But the overall impact to the rest of the network is going to be pretty low, correct?
Absolutely. It's going to be very targeted.
Yeah. So instead of doing ARP cache poisoning and pivoting that traffic between two systems, you can effectively do what Responder does, but not with LLMNR, not with mDNS, not with DNS, but actually doing that using these stack or these stale ARP requests, correct?
That's correct. We just assume that stale IP address configuration and we get traffic.
Yep. So I've given you the link of where you can get this tool, and I'm going to make you the presenter, Justin, so you can actually walk us through a demo if you're ready.
Absolutely. Thanks, John. Really appreciate the introduction there. So effectively, I probably should discuss the environment just a little bit. What we have here, this is my home network. I have an environment set up such that I've got a bunch of pings happening in the background. And I'm going to be generating a lot of ARP traffic. I also have a host that is going to simulate a SNAC misconfiguration. That's going to be on this host here. You can always tell it's going to say iron. That will be the host that is affected by the SNAC misconfiguration. And what I've done here, this is another little tool that I've written called Swisslog. It's going to generate a constant stream of syslog requests. It's going to try to log records to the IP address .101. Now, currently, there is no host that has that IP address. So in this way, we are going to be effectively simulating an instance where we have a stale IP address within the environment. So what I'll do is I'll go ahead and enable that. We see that running. And it's worth mentioning that what we see here, this actually manifested in a recent test that I was on. There was a host that was configured to log records from a web server that actually contained usernames and passwords. So upon exploitation, we actually got free creds, which was quite surprising. So now that we have that traffic going, we're simulating a SNAC, I'm going to turn on Eavesarp. Now, at this point, it is going to be 100% passive. I'm specifying the capture command. There's also an analyze command. We can talk about that later if desired. But right now, we're just going to passively capture ARP requests as it crosses the wire. And we quickly see 3 hosts pop up. So .2, if you recall, this is the host that is misconfigured with a SNAC. This is the stale IP address within the environment. No host has that right now. And you'll notice some very close similarities to NetDiscover, for instance, at this point with what we're seeing. But we have a couple of different columns. The far right here, we have stale. This indicates whether or not the target IP address is stale. And then we've got SNAC. Now, right now, since everything is passive, we're just kind of passively collecting all of these packets, and we're analyzing which are communicating with one another. And we amass a series of IP addresses we inventory from the senders, and we can kind of infer, since .99 here is also the target there, we know for a fact that it's not stale. Now, we don't know for certain if these are stale or not, just because that host may be silent. If we're in an environment where it's okay that we can generate traffic, we can turn on active resolution capabilities. The first one being, we'll wait for the processes to close here. ARP resolution. And once we turn on ARP, now you'll notice we didn't have to restart the capture either. So all of our traffic is being saved to disk in a SQLite database file. So we pick up right where we left off. And now that we've got active ARP resolution enabled, we can now confirm whether or not this is a stale target. And if it is, we know that this sender is affected by a SNAC. It's kind of neat. So at this point, we know something is going on here. It's very noticeable traffic behavior, but it might be nice to do a little bit more reconnaissance. I mean, odds are you've probably ran nmap, and you probably know what's running on the target at this point and the sender, if the target exists. But we can take it one step further, and we can also infer what the target and sender might be used for. And that's the second stage of active reconnaissance. We could turn on DNS resolution as well, and it will then return to us.
And that sometimes, Justin, that can give us an idea as far as what that server actually is. Is it a logging server? Is it a file server? You have DeskJet popping up in here. So then we can get an idea of what types of protocol or service we should be using to try to capture credentials, correct?
100%, absolutely. And we can clearly see, as John mentioned, we've got DeskJet in here. We've got a Kali host, which is actually what I'm on right now. And we have syslog. So that's a pretty strong indicator that that target is a syslog server. We also have another interesting column here, but I can talk about that after we demonstrate what we can do to try and capture syslog information. So for those who aren't familiar, in Linux and in Windows, as a matter of fact, you can take an interface and you can alias it with multiple IP addresses.
And I want to kind of interrupt. We had a lot of people that are like, so you have to ARP cache poison. You have to ARP cache poison that IP address. And what you're talking about is no, we don't have to use ARP cache poisoning. We're just going to say you're trying to get what's your stale address on the screen. Sorry, I've got windows all over the place.
Oh, no, it's no problem. The stale address is .101.
Okay, cool. So instead of trying to do ARP cache poisoning, we can literally stand up an interface that has that IP address. So you're
Correct.
not really doing ARP cache poisoning. You're basically standing up and saying, yo, I'm that IP address, and now the traffic's going to come to you. So sorry about that. Continue.
No problem at all. So yeah, as John just said, so what we can do is we can take an interface, we can give it multiple IP addresses, and then any time that we see an ARP request or our interface sees an ARP request for that IP address that we have aliased, it's going to respond with the same MAC address. So as we'll see here in a few moments, I can actually turn on, we can reflect MAC addresses in this output as well. We will actually see multiple MACs associated with IP addresses that we have under control. And that is just what is happening there. So what I'll do now is I will go ahead and alias my interface with a second IP. We're going to alias it with the target, which is the stale IP here. And once that happens, we should start seeing syslog traffic, be the demo gods happy anyway. So what I'll do first is I will enable TCP dump, and we can clearly see that we have ARP traffic coming through. And now if I alias, this is the command that we'll use to alias my interface with the stale IP. And once that happens, we should see interesting things happening. So if you recall, these are the log records being generated here. Free data.
Funny, the sirens kick up and everybody's like, they're coming for you, Justin. Bad boys, what you gonna do? And by the way, I've had like 9 people ask, are you using tmux or are you using mosh as your shell right now?
I'm using bash as my shell and tmux as the what is it? The TTY, or not the
Okay,
TTY.
cool.
But the
so, and people are like, oh, cool stuff. Check out
Telephone.
tmux and then also check out mosh. Sorry, so many questions on that. Sorry, go ahead.
No, it's no problem. And I'm kind of moving quick, guys, so sorry about that. I know that we've got a timeline. Okay, cool. So at this point, we know for a fact that we can still syslog information, which is kind of neat. Now this leads me to the final column in the output that I referenced earlier. Once reverse DNS resolution is applied, we have pointer addresses. Eavesarp will take it one step further and also do forward lookups, and then compare the value returned from the forward lookup. So we can see here what this first IP address is. That is the IP associated with the pointer, but it is not the same IP address that is associated with the forward address. That's a potential indicator that the server was just moved to a new IP address, the original server that is now stale, or the stale IP address is associated with the old server. The old server has been moved to 102. So this presents an interesting attack opportunity, potentially anyway. If that host is alive, we can enable IP forwarding on our host. And after that, we can also turn on masquerading, and then we'll effectively begin capturing all of the traffic that is originating from .2 in this case, which is our sender, and redirect it upstream to 102. And in the process, should credentials be disclosed, anything like that, we will capture that information, and it's free. No spoofing occurred. So what we'll do now is I will enable in this script. I already have it here just so that way I don't have to remember the commands to run. Got a simple bash script that's going to enable all of our IP forwarding for us and everything like that. So we're going to make magic. Now that that is enabled, I will turn back on TCP dump, except this time I'm going to capture on port 445. Now, I notice we're not catching anything at the moment. And again, this is the SNAC host earlier that I'm now operating from. So I'm effectively going to be emulating a login over SMB to the stale address.
And are you forwarding that authentication, or are you going to try to capture the hashes for that authentication?
I'm just going to capture the authentication traffic at the moment.
Okay.
That will be captured here in TCP dump.
Okay, awesome. Which would have the SMB password hashes in it as well.
It would. And on top of that, we would actually be capturing any other information that would be on the share as well. So
Nice.
if there were, sensitive files transferred, anything like that, we would capture it. Now you can see that we clearly have additional traffic. Here is our SMB protocol negotiation request. So this is the initial steps toward authenticating the host. TCP dump doesn't do a good job of dissecting and presenting the hash here, but had we saved it to disk, we could always use something like, well, actually, I could do that real quick. Let's see. Now I'm actually going to be saving those packets to disk. I'll authenticate again. And now we can use something like pcreds to extract the password hash. Let's see. Oh, bummer, it didn't work. It didn't save it to disk.
I think you missed the authentication. You need to re-authenticate.
Let's see. Give it another whirl here.
This is what happens. Yeah, let's just do that on the fly. Sure,
Yeah.
why not?
Lessons were learned.
Yeah, now try to re-authenticate.
The demo gods have been kind up to this point, so I had high hopes.
Yeah.
That is unfortunate.
So there's a number of things that you could do, right? I mean, this is just one of those, like you're
Correct.
forwarding it on and trying to capture it. You could fire up in packet and then have that share actually be present on a system, and then you would capture password hashes. You could also fire up like something, like I said, responder, and stand up multiple services. If you don't know what that is, and responder would stand up like HTTP, and then it would start up, an SMB server and FTP and all those different protocols, and you could have those servers stood up and then redirect it there as well. So the point is, you're redirecting the traffic through your demo's computer system so that you have the ability to intercept the packets and you can see that traffic going through. And you could do just about anything at that point, right, Justin?
You're in complete control.
Yep. So, all right. So go ahead and keep
this
going.
worked live, so.
Yeah. Well, we got the packets to go through, right? So the packets are definitely running through. Do you want me to see? I've got that. Yep. And I do have our demo. Like I told you, we should record it before. So I think I have that here. So
I think that I may not have gone through the hash dump at that point in the video. This was completely on the fly.
Oh, okay. So you do have the hash dump though on the video someplace else?
I do not on the video. Let's see.
Cool.
John, there's a question that just came in from JG.
Go ahead and shoot it.
Says a dumb question. You are forcing the SMB authentication in your initial setup. The only thing the script is doing is forwarding log data to the host. If that's all it's doing, sending log data, how do you force SMB auth, for example?
So remember, what it's basically trying to do is it's trying to access a system that's not there. Okay. So it's very similar to link local multicast name resolution. You're basically saying, hey, who has this IP address? The system that's running, responder will say, hey, I'm that IP address. And then as soon as that system tries to come to you, that's when you capture the authentication. And you're doing something very similar here. You have a system that's got a stale ARP entry that's saying again and again and again and again, and it's basically saying, hey, I'm looking for this IP address, who has it? Who has this IP address? Who has this IP address? And Justin's tool is ability to detect those systems that have those stale SNAC addresses or those stale network addresses. And then he can stand up and say, I am in fact that computer system. And you don't even have to do ARP cache poison to do it. You just stand up and you say you are that IP address. Now that system that was looking for that IP address now has a home. and now it comes directly to you, and then you're able to capture the authentication via SMB or FTP or whatever protocol you want as well. So this is basically a continuation of those NetBIOS name service and link local multicast name resolution attacks. This is yet another way that you can bring your different attack tools to bear as well.
And John, so what's
yeah.
the prevention or detection methodology for this?
Cool. So I'll throw this over, and this is all in the blog post as well that Justin wrote up. He has an entire section dedicated to it. Justin, do you want to talk a little bit about the prevention and blue teamer side of this?
Absolutely. So of course, we've already discussed about the key indicators of a stale network address configuration, and that is very, very frequent ARP requests, often in a very small window of time. It depends on the protocol and the client in use, but that's the key indicator. So that's something to monitor for. Something like Eavesarp would be a key way to extract that.
And if you're looking at Eavesarp, it can definitely be used as an attack tool. There's no question. But if you want to go to different network segments and you can fire it up and just see, I mean, this isn't launching an attack on the network. It's almost completely passive unless you're doing resolution, correct?
Correct. It is 100% passive unless we're doing ARP and DNS resolution. And I'm actually considering extending the capability so that way you could do syslog from it as well. So it maybe set some thresholds so that way it would log that events that would appear to be stale.
Yeah, and now there's some other questions that we've had. Let me go through them. This is like ARP cache poisoning without the poisoning. It's basically just abusing static IP address entries. And I think that's a good way of putting it, correct?
Absolutely.
It's abuse. I don't know, that sounds harder. Like I said, SNAC, the stale network address is really probably one of the best ways to actually look at it as well. So it linked to the blog post. Jason, do you have a link to that blog post? Now, Luke had a question. He said, what size of a state would you say you would expect to find SNAC? Like, how often would we expect to see this? I think as soon as you came up with this, it worked in your test that you were on. And I think we've had 2 testers that have found this exact same thing showing up. I think it's been 2, hasn't it? I think
correct.
Kelsey did, and I don't know, I might be getting confused. So this isn't some like weird, rare edge case. We've actually seen it a bunch since you wrote this tool, what, last week when you wrote this tool?
Memorial Day weekend is whenever I first dug into deriving it.
What's that?
Memorial Day weekend was when I wrote it.
Yeah, and then you went all the way through that as well. So the next one was, in an environment with LLMNR off and SMB signing enabled, can we still use this method to access a service or a resource?
Yes.
Cool. So, and the way that would work is, once again, if you're looking at just SMB, SMB is just one protocol, right? It is one protocol for authentication. You can actually go through and you can do authentication via HTTP, FTP, tons of additional protocols, and sometimes just being able to go through and capture those packets is helpful. Now, a really good question just popped up. What about the option of relaying with NTLM Relay X? Would that work in this scenario?
Yeah, absolutely. So long as we are, capturing that information, what we'd have to do is you'd have to apply the IP table rules similarly to what I was running or what I ran earlier or applied earlier. And Laurent Gaffey, actually, I link to this post where he discusses this in the blog post that we will be releasing or has been released. I'm not sure if it's out there yet.
It is released
in there. Awesome.
Okay. And I think Jason shared that link with everybody as well. So you have that.
Yep, it's in the chat window.
Cool.
And if you're watching the recording, then it's just look down below.
Yep.
But after applying these rules, whenever that SMB session hits the appropriate interface, it's effectively just going to be relayed on your behalf to the NTLM Relay X listener, and then it will then forward it upstream, forming a relay attack.
Very cool. Now, another one from Michael said, is there an example situation where what is an example situation where stale IP address would exist? So far in your test, what was the one that you, of course, not mentioning the customer, what was the scenario that stale IP address was there?
We were in a network segment that was almost like a DMZ was where we were testing. And there was a log server there, and that log server was configured with a configured with a SNAC. and that was the syslog server, right? So we're just kind of piping syslog requests out to an upstream host, but that upstream host has gone offline. So we just effectively started intercepting the syslog traffic as it came through. That's just one example, but I mean, especially something like a development environment, anything like that, like if you have hard-coded addresses in a SQL for an SQL server in an SQL client. So it definitely depends on the environment, but there are some instances where it will happen.
Yep. And once again, to kind of drive this home, I keep on saying this again and again, these types of attacks, right? Like LLMNR, mDNS, NetBIOS name service, this is just really adding one more thing that you can look at as a security assessor, that you could say, okay, how can we take over systems looking for other systems on the network itself? So another question from Marvin. Say there's a server that we know is being communicated with a client. That server can be crashed somehow. Can't this be used to force a SNAC condition? Ow. Yeah, let's not do that. I would say the answer to the question, Justin, is yes.
But would you want to? Yeah. What's the impact going to be there?
Okay. And then the other thing I wanted to ask is, what the hell's with the ponies?
So that's just a little aesthetic feature, if you will, of Eavesarp. So you can apply different color profiles. So earlier, whenever we were just looking at raw text, now we can clearly identify which hosts represent SNACs and which hosts represent stale IP addresses. It's just easier to read, in my opinion.
Yeah, because the ponies help. Somebody just mentioned that broken half disconnected GRE, generic routing and encapsulation tunnels, would do the same. So if your VPN and all of a sudden that goes down, it's going to start sending out ARP requests for a system it used to be able to connect to as well. So it's funny, whenever we start thinking about it, it's funny because we're coming up with a bunch of scenarios. Somebody said they're unicorns. Are they ponies or are they unicorns? Nope, those are unicorns.
Those are definitely unicorns.
Sorry, they're not. I couldn't see it. It was small, so we've got unicorns. So it will not work outside of layer 2. That is correct. You'd have to be on the same local network segment as a system that you're absolutely targeting at that specific point. So, all right. So any other questions, or Justin, do you have some more that you want to kind of cover here?
So
I see you're still typing.
At this point, I'm just playing with the tool that I've created. We have complete control over the columns that are displayed as well, which is kind of what I'm wanting to show now. So that way you only get the information that you want. And yet another different color profile here.
It's a rhino. Is that in honor of Michael?
That is in honor of Michael. Good catch there.
Very good, the white rhino.
Yeah. You don't know, he requested that I do that, and why not?
Okay, here's a really cool question. Somebody said, if I have a switch that protects against ARP cache poisoning, will it stop this? And I'm gonna guess no, because you're not actually ARP cache poisoning in this scenario. You're basically becoming the IP address it's looking for, right?
If that switch or other network component is enforcing dynamic ARP inspection, I believe that it will indeed remediate this vulnerability, because it's keeping a log of the IP addresses that have been allocated by DHCP. And if we assume that IP address,
but that table is going to time out. So if you have that system that goes offline and it's been off for like 2-3 days, it's going to lose track of what MAC address and IP address it was, because those tables only stay alive for so long.
That's true. So I haven't tested this yet. So it sounds like we've got some conflicting opinions there. The reason I have not messed with dynamic ARP inspection that much, it would just be very interesting. I was always under the assumption that it monitored the addresses that were issued by the DHCP server. And if the DHCP server did not issue the IP address to that associated MAC, then it wouldn't honor it. But it sounds to me, I may not understand how it works.
It's going to depend on it. So there was a number of different ARP cache poisoning tools that would take advantage of those situations, that would do ARP flooding. So basically you would set up that CAM table and it would learn, okay, this DHCP server gave this IP address, gave this IP address, gave this IP address. And years ago, you used to be able to flood that out fairly quickly. Now they got better over time, but even those entries, unless you're using static hard-coded IP to MAC addresses in a CAM table, those do refresh out. Like if it doesn't see that IP address for an extended period of time, it basically just kills it. Now, the one thing that you might be right on is if it has to be a first, then a second scenario, like it has to come up and it has to say, okay, DHCP granted this IP address, and then I'm going to authorize it. But I don't think that's turned on in most switches that are doing dynamic ARP inspection.
Okay.
That is one of the things they're looking for. But if you stand up a static IP address, I don't think that they actually detect that, but I could be wrong. And that's probably vendor to vendor as well. So
that's interesting. If any of the attendees have dynamic ARP inspection enabled, I'd be really interested to hear if this tool works for you.
Well, dude, and this is one of those things I think a lot of us are going to be going back to the drawing boards and looking at as well. So, boo, it crashes on OS X. I think it's probably a Python version, and make sure that you do the pip install requirements before you set up. This is Python 3, right?
Yes, correct. And yeah, it's definitely not going to work on anything but Debian Linux.
So, because Debian is awesome. Yeah. So what does Debian provide that you need, or is there a way to make it more portable with other distributions?
You know, I do not have an answer for that question right now. I just know that a lot of it is definitely very Linux specific in its implementation.
Yeah,
yeah. Everything from the SQLite interface, it uses SQL Alchemy. I'm unsure if that is compatible with Windows. And this is a discussion that I've had with a few friends. I would like to work toward getting potentially a PowerShell version of this going. I feel like would be an interesting project.
That would be awesome. Of course, that just sounds painful to me. I don't know about you. Python's so much easier to work with. I'm not saying better. I'm just saying easier than
I mean, I don't program in PowerShell. I survive it when I have to. Yeah.
John, we got two other questions here. If an attack came upstream via proxy ARP, would you still be able to count the failed ARP request?
Attack came up via proxy ARP. Would you still be able? I don't know.
I
might be missing something. I might be missing something.
Proxy ARP is still a little bit of black magic to me, to be honest. That's something that I would have to research a little bit.
All right, the other question is, would you touch on the attack related to mDNS? I'm familiar with LLMNR and how that works with responder, but not mDNS.
So there's there's 4 different main ways traditionally, and Justin, jump in here if I'm wrong. It was like responder will work with LLMNR, it'll work with NetBIOS name service, it'll work with mDNS, and then kind of in a separate category would be WPAD. Similar, but not the exact same. So mDNS is just basically it's broadcast out to the rest of the network, and then you can respond back to mDNS requests in similar way that you would LLMNR. Did I state that right, Justin?
Absolutely. It all boils down to the fact that we have decentralized name resolution occurring and it's broadcasted. So any kind of protocol that operates in that nature is going to be vulnerable to poisoning attacks.
Cool. And John is just telling me not to argue with you. He said he's always correct. Don't argue with Justin. So I guess I stand corrected. I learned something today, Justin. So that's good to know.
I have opinions and I stick by them.
Yeah, me too. So, all right. Well, I think we're probably at the point. I think that we're at the point where somebody just recommended a tool, Evil SSDP, and I think that's 10. I don't know what Evil SSDP is, but yeah, it sounds like another protocol that you can hijack. So John has better stories. Thanks, Mike. That's a great consolation prize. So with that, anything else to add to close this out, sir?
Not at all. Nothing for me.
No. I want to say thank you very much, everybody, for attending. Just fantastic job, Justin. And the fact that he threw this together so fast, like it was Memorial Day, and I said blog post, and you're like, I'm gonna have to do it next week. You did it the next week, and then I'm like, webcast, and you're like, sure, let's do it. That was absolutely awesome. That was very, very, very cool. And we hope to get you going on getting on some other things as well. And if you guys have any recommendations and things that you'd like to see the tool do, once again, go to the GitHub repository and flame Justin with comments, because that's what GitHub is for. So thanks again, everybody.
Send me all of your pull requests so that way I can
send me all of your pull requests, all of them, all of them. All right, thanks again, everybody, and we'll see you at the next webcast.